Hello again. We are back for part 3 of the Trig Mastery Check Solutions set. Here I am on number 11. This is going to be a picture where we are, or a problem where we are drawing a picture and then getting information from that picture. So here is our hiker. Our hiker walks from the city of Gamley west for 65 kilometers. So west for 65 kilometers, then turns south for an additional 50 kilometers, where she arrives in Freetown. How far from Gamley? Is it from Gamley to Freetown? So find x. And what is the bearing angle from Gamley to Freetown? There's our theta. Okay, so we could do this in a couple of ways. First, let's find the distance from Gamley to Freetown, and then we'll find theta. So I'm going to use the good old Pythagorean theorem. Equals x squared. So that's the side squared plus the side squared equals the hypotenuse squared. So 60 squared plus 50 squared is equal to 6100. And then I'm going to take the square root of 6100. So I'm going to second square root my answer and get 78.10. X equals 78.10. So approximately, so Gamley is approximately 78.1 kilometers from Freetown. Now, the bearing angle theta, well, I can find that because here's my angle, here's my side opposite, and here's my side adjacent. So I could use the tangent function. Tangent of theta is equal to opposite, which is 50 over 65. So if I go back to the calculator here, and I do second tangent, 50 over 65, that is going to give me 37.57 degrees. Whoopsies, wrong page. 37.57 degrees. Okay, now we move into graphing, and I'm going to graph one cycle of the sine curve. Well, the sine curve looks like this, but it's not enough to just make a sketch. I want an accurate graph of that sine curve from 0 to 2 pi. I know that that's going to be the period because I'm looking here and the b value in here is 1. There's no amplitude, or the amplitude is 1, and the function hasn't undergone any phase shifts or moved up or down. So if you recall, here at 0, the sine is 0. At pi over 2, the sine is 1. The y value is 1 on the unit circle. At pi, the y value is 0. At 3 pi over 2, the y value is negative 1. And at 2 pi, the y value comes back to 0. There is one cycle of y equals sine theta. Now I'm going to graph y equals 3 plus cosine theta, and I would suggest maybe rewriting this as cosine theta plus 3 to be able to identify that that is the cosine curve moved up 3 units. So our cosine function looks like this, the parent function for cosine. As I take a look at this, the amplitude is just 1. There's been no reflection. There's been no phase shift. The shift is just up 3 units. So I'm going to take the cosine function and I'll do it over here, move it up 3 units. So normally it starts at 1. It's going to start at 4. Normally it goes down to negative 1, but I'm going to move it up 3 units. So negative 1, 1, 2, 3 units. It's going to end back up here at pi at 4 because it's moved up 3 units. It's going to be at 2 because it's moved from negative 1 up 3 units to positive 2. And then somewhere in between here, it's going to go through that center line. at 1. Okay, here's the graph of y equals cosine theta plus 3. I need to put in these values of 0, pi, pi over 2, 3 pi over 2, and 2 pi. Okay, the next one is y equals sine 2 theta. What I'm looking at here is an amplitude of 1, a b value of 2, a period of 2 pi over 2, so a period of pi, and no phase shift. I don't move left or right or up or down. And there is no reflection. Okay, so here's my sine curve with an amplitude of 1. I can sketch that regular sine curve and then I can fill in the points in between. 0, pi. This would be pi over 2. This would be pi over 4. This would be 3 pi over 4 because I'm going pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. And the last graphing question, y equals 2 cosine negative 2x plus pi over 2. I need to do a little bit more work for this one. I see that the amplitude is 2. The b value, I need to factor out a negative 2. So cosine of negative 2, and then that would be x minus, let's see, pi over 2 divided by 2 is the same thing as pi over 2 times 1/2, so that is going to be 1/4, or excuse me, pi over 4. So that's x minus pi over 4. All right, taking a look at this a little more closely, I am looking at a negative 2 here. What does that mean? Well, we could take a look at the graph on our calculator at the end, but I want you to be thinking about how that's going to translate in the graph. Notice that the b value is negative 2. How that applies to the period is, well, the negative doesn't factor in because I'm taking 2 pi over the absolute value of b. So that's 2 pi over 2, and so that's going to be a period of pi. And with an amplitude of 2, a period of pi, and then I have a phase shift where this graph moves to the right, pi over 4 units. So when I make a sketch of this, I'm going to go over pi over 4 units, and I'm going to end at pi. So that means that if I add those two up, I get an end point, because I want to end at the start plus the period, because I only need one cycle. So I'm going to add pi over 4 to pi and get 5 pi over 4, and that is going to be my endpoint. So I know the point in the middle has got to be 3 pi over 4, and that these points in between have got to be 2 pi over 4 and 4 pi over 4, which would be pi. Okay, the amplitude is 2, and the and we took care of the phase shift, so we're going to start here with the cosine curve, which means we're going to start up high, and that we are going to go down halfway to negative 2 and then come back up to 2, and at the midway point we're going to cross through that center line, that axis, which is at the x-axis. Okay. There is the graph of y equals 2 cosine, oops, we forgot in that negative 2, of x minus pi over 4. So now we've got to think about what that negative 2 means. Well, let's take a look on our calculator and see if we can get a picture of this. So y equals, I think I need this to be in radian mode. And now I can get back to y equals, that would be 2 cosine. Let's type it in just as it is, negative 2x minus parentheses pi over 2, close parentheses. Let's look at that graph. It may not look all that helpful, so what we need to do is look at the window and actually zoom. I'm sorry, I want to zoom to zoom trig and hit enter. Let's see if that's going to change anything. It is not, of course. It's not working when I need it to. Mode, radian mode. Okay. y equals, there's our equation. I'm looking at the zoom, and it should be zoom trig. There we go. That's better. If I hit enter. So now what I'm looking at is a picture of the cosine curve. Hang on, stand by. We're gonna look at this again. I may have made an error in typing this, or in typing it in, or on the test itself. So stand by on this one. I can answer questions about it if you chat me about it. But I'm going to move on to question 13, which is write the equation of a sine function with amplitude 5, period 4 pi, and a phase shift of negative pi over 4. Okay, so the amplitude is going to be 5, and I'm working with a sine function, so y equals 5 sine. I have a period of 4 pi, so working backwards, 2 pi over b should be equal to 4 pi, and so what that means is that b times 4 pi is going to equal 2 pi if I just make that a proportion and cross multiply. I'm going to divide both sides by 4 pi, and then what I get is 1/2 for a b value, and so that value goes right here next to the x, and a phase shift of negative pi over 4. So negative pi over, well, we've got to figure out exactly what that needs to be and work backwards. If I will end up factoring out 1/2 x minus pi over 4, that's what I want it to look like, then in the beginning what it needs to be is pi over 8. Here is the graph that has an amplitude of 5, the equation for a graph that will have an amplitude of 5, a period of 4 pi, and a phase shift of negative, oops, there we go, negative pi over 4.